Greetings, we are from Group 6. Today we would like to discuss about the case study of hazard identification, risk assessment and risk control at high voltage laboratory in FKTE, which is in Pink Building. We are consist of 4 team members starting from Yogitra Ganesan, Karthik Murthy, Mishalini Kumar and Ravinder Lechmanian.
In Malaysia, occupational safety and health is to protect workers and create a safer work culture with laws and safety practices. Occupational Safety and Health Act 1994 is to ensure employers and employees work together to maintain safety. Factories and Machinery Act 1967 is to ensure the safe use of machinery at workplace. HIRAC is a step-by-step method used to manage workplace risk. Hazard identification is to identify potential physical, chemical, biological or psychological hazards. Risk assessments evaluates how likely a hazard is to happen and how severe the effect could be using a risk matrix. The assessment is carried out based on table 1.1, 1.2, 1.3 and 1.4 as shown. The relative risk is calculated by multiplying likelihood and severity. Risk control is based on the hierarchy of control, which starts from eliminating the hazard, substituting hazard, using engineering or administrative controls, and lastly to the least effective method, which is PPE.
I'm here to present about the case study area. The high voltage lab at Makmal Voltage Tinggi at the Faculty of Electrical Engineering Technology, UNIMEP, act as an essential facility for electrical engineering research and teaching. The lab is primarily used for high voltage testing, insolation analysis and understanding the behaviors of electrical components under extreme voltage conditions. It plays a central role in subjects such as high voltage engineering, electrical power systems. Given the nature of experiment conducted, the lab strictly complies with the electrical safety standards and university regulations. Clear signage on the door, Awas Voltan Tinggi, danger high voltage, serves as a constant reminder of the inherent risk involved. The person in charge of the specialized lab is Mr. Chasman Azliman bin Musa. He guarantees that all the lab operations follow the safety procedures and academic standards necessary for high-risk settings.
The first hazard is agronomic hazard under the type of physical hazard. The source of this hazard is under machine, referring to lab stools. The stools are high and uncomfortable, lacks lumbar support and has no adjustable height, unsuitable for prolonged sitting. This can lead to musculoskeletal disorders. Risk assessment is carried out by identifying likelihood, severity and relative risk. Likelihood is 4, severity is 3, calculated relative risk is 12, which is medium. Risk control methods are substituting hazard by replacing with agronomically designed chairs with lumbar support, adjustable height and footrest. Engineering control by installing footrest beneath workstation with adjustable height lab tables. Administrative control by encouraging students to take brief standing or stretching breaks every 30 to 45 minutes and introducing rotational tasks. PPE by issuing ergonomical seat cushions or portable lumbar supports.
I'm here to present about the hazard 2. The type of hazard identified in the high voltage lab is chemical hazard. The chemical hazard in this scenario comes from the solder wire. Flux inside the solder wire often contain rosin acid-based chemical that, when heated, release toxic fumes. When soldering, the iron is heated and comes in contact with the flux solder wire. With the flux melts and release chemical fumes. Inhalation of these fumes can lead to headache and can irritate eye and skin, especially in poorly ventilated area. And continue with that, the risk assessment for this hazard is the likelihood is 4, severity is 2 and relative risk is 8, which we consider as a medium. Medium risk require planned approach to containing the hazard and apply temporary measure or if acquired. Action taken must be documented the risk assessment from including date from complication. And continue with that, risk control for this hazard. The first step will be to substitute the solder wire with a lead-free or rosin-free alternative, which produce fewer harmful fumes. Secondly, use the engineering control such as using a fume extractor or ensuring the soldering is done near a ventilated area can significantly reduce the amount of toxic vapor inhaled. Lastly, personal protective equipment, which is PPE, such as face masks, safety goggles and gloves especially when the other control methods are not fully in place.
I will now present hazard 3, which is involve the risk of electric shock during the high voltage testing. The source of this hazard is the conductivity metal sheet using in this test area. If a fault or leakage occur on the sheet become alive, anyone step on it without proper insulation could suffer a fatal shock. The risk assessment shows a high risk of 20. We proposed a high risk of measurement to control this risk. First is eliminate the use of high voltage where possible, or substitute expo part with the shields one. Engineering control like barriers, insulated mat or interlock are highly effective. Finally, the extremity control such as lock out or tap out procedure, safety training and clear signages are essential to ensure the safe work practices. Together, this measurement from a comprehensive risk mitigation strategy. Next, we address hazard 4, which is physical hazard involve unsecure equipment due to the vibration during the high voltage testing. The source is metal sheet on the floor, which can transmit mechanical vibration from the heavy electrical device like a transformer. This vibration can cause unstable equipment to shift, leading to injury or equipment damage. This risk assesses a medium with the likelihood of 4 and severity of 2. To control this, elimination is the ideal but not always practical. Therefore, engineering control such as bolting equipment and using anti-vibration mode are highly effective. Administrative control like regulation inspection, staff training and maintenance further reduce risk. A combination approach is recommended to ensure the safe and stable testing environment.
I will now present the hazard 5 related to soldering iron use. First, the hazard identified is mechanical hazard due to overheating. The soldering iron tip can reach extremely high temperatures between 300 to 450. Accidental contact with the tip or molten solder can cause serious burn, for example, when adjusting the iron or during the unintentional bumps. In the risk assessment, likelihood of this occurring is rated 4 and the severity is 2, giving a risk rating of 8, which is categorized as a medium. We propose 3 types of measures to control this risk. Engineering control include using proper soldering stand, heat resistant mat and fume extraction system to prevent the direct contact. Administrative control involving safety training and enforcing procedures like switching off the iron after use, displaying the warning sign and conducting tool inspection. Finally, PPE such as heat resistant gloves and goggles, lab coats provide additional personal protection. In conclusion, a combination of all this control is essential to effectively minimize the risk and ensure a safe soldering environment. In the discussion, we can say that the high voltage lab at UNIMEP has taken a significant steps to enhance the safety and the environmental standard through the effective use of high-rec, identifying and controlling the risk like electrical shock, chemical exposure and agronomic issues. This effort ensures a safer environment for students, staff and visitors while also fostering a safety-first mindset among the future engineers. Environmentally, the projects promote sustainable practices by using a safer materials, improving the ventilation and maintaining the energy efficient equipment, which helps reduce the toxic emission, prevent fires and support green engineering principle. Overall, the initiative not only protect the users but also contribute to long-term societal and environmental well-being.
In conclusion, the high voltage lab has agronomic, chemical, electrical, mechanical and physical hazard. Using HIRAR, control measures were identified from hazard elimination to PPE. These are crucial to ensure a safe and healthy lab environment.